It's DUG24. 24 hours, 24 sessions, 24 speakers, 100% Microsoft Dynamics. It's unparalleled, unprecedented, and undeniable fun with your hosts Beau Schwieso and Bobby Small. Let's get into it with another episode of DUG24. Down to our last 2 hours. Insane. We've got 1 minute, but we can bring Radovan on. Radovan, I know you're here, and I think you've made your presenter, so you should be able to come off camera and get yourself going.
Yes, thank you. I think it's supposed to work. I'll share the screen right now, and maybe you can confirm if you can see it, actually. I guess so, you can.
Yep, you're good.
All right. Good to know. So let's get started, and thank you, Bobby, for introducing me. I would start with one statement, and it is that most Power Platform solution, it don't fail during the development, but it fails after they are successful. Let's imagine you build a Power App solution. Every enterprise solution starts small. The first version works great. I mean, users love it. Then more people start using it. The business asks for another integration. Then come new requirements. More data, more usage, and more complexity. Then one day you realize you are no longer maintaining a Power App. You are maintaining a business critical platform. And that's exactly where most problems begin. Not because Power Platform doesn't scale, but because most solutions were never designed to scale. Today, I'd like to share some of the lessons we learned while solving these challenges, and how those lessons helped us build solutions that continue to scale. But maybe you will be asking, from where do these lessons come from? My name is Radovan, and I am a digitalization engineer at Siemens Energy. For the past few years, I've been building enterprise Power Platform solutions supporting business critical processes. During that time, I've seen solutions evolve from small proof of concept into applications used by hundreds of users across multiple teams and countries. The lessons I'll share today don't come from books or documentation. They come from mistakes, redesigns, production incidents, and these things we wish we had known much earlier. When people hear the word scaling, they think more users, more integrations, more data, more features affects the performance. I mean, that's right, it does. But besides that, it affects architecture, maintainability, deployment, and also monitoring. Scaling changes every aspect of our solution. Now you might ask, what actually breaks first? Is it deployment, or maybe you will be asking, is it the performance? No, the answer is quite simple. The answer is all of them. But let's start with the architecture. Every one of the areas we discuss become a challenge. But when we look deeper, many of them had one root cause, the same root cause, the architecture. And let me show you one real example what I mean. This is simplified version of one of our internal app. On the left, we have all of our projects. Then I select the project, and the application automatically loads all work packages belonging to the project. And not only that, because when I select the work package, I immediately see all stages for that specific work package. So basically, from the user perspective, everything feels very simple. And that's exactly how it should be. Users shouldn't think about architecture or how it's built. They should simply click the button and everything should work. Now let's create a brand new project. The user enters the name, the country, region, serial number, number of work packages, number of stages. Nothing unusual, just a form, and user clicks create. And this create button is where our architectural story begins. Because from the user perspective, they clicked one button. But from the system perspective, that's a different story. That single click starts creating an entire hierarchy. So one button becomes, in that case, 30 work packages, 120 stages. In total, more than 150 related records. Every one of these records has its own identifier. Everyone belongs to the correct parent, so relationship must exist. Everything has to be created in the correct order. Because if something fails, you don't just lose one record. You risk leaving the whole project inconsistent. So how did we approach that? How did we implement this? By evolution of our architecture. And as I'm mentioning evolution, let's go back to our very first implementation of this architecture. Our first version kept everything inside Power Apps, just the Power Apps, nothing more. And the entire process was driven by the nested for all loops. At that time, it felt like the most natural solution. The user filled in the form and clicked a single create button. Nothing complicated so far. And the next application look at the number of work packages the user requested. Let's say the user entered 30. The app simply looped 30 times, creating one work package in every iteration. Then we repeated exactly the same idea for stages. If every work package required 4 stages, let's say in that case, another loop started inside the first one. For every work package, we created 4 related stage records. So one button click could easily generate more than 150 related records. If we translate the diagram into the code, this is basically what it looks like. Honestly, this solution was very easy to build. Everything lived in one place. Just Power FX inside Power Apps. No additional services. No extra infrastructure. And that's exactly why it felt right. The UI triggered the business logic, so keeping everything inside the app seemed completely natural. And most importantly, it actually worked. I mean, users could create the project. The data was generated correctly. I mean, everyone was happy. Or at least for a while. Until the application started growing. And then what happened? the first email started arriving. We thought it was just a one-off issue. Then another email, and another. Eventually, we realized the problem wasn't the users. The problem was our architecture. We asked ourselves, why is the user interface responsible for creating hundreds of records? It shouldn't be. The UI should collect user input. The business logic should live somewhere else. Instead of doing all the work inside Power Apps, the app became only a client. It collected the user's input and delegated the entire creation process to Power Automate. That's how we created second version of our architecture. The responsibility moved. The button no longer created records. It simply started the flow, and from there, everything happened in Power Automate. Suddenly, our architecture had clear responsibilities. The UI becomes smaller. The flow becomes responsible for orchestration, and the database only stored data. Or at least that's what we thought. Because another problem appeared. Yes, the architecture was cleaner, but the flow was still creating every record, one by one. Hundreds of API calls, hundreds of requests. We moved the problem, but we didn't eliminate it. So we ask ourselves one more question. Are we orchestrating or are we executing? And we realized one thing. Power Automate was a much better orchestrator than Power Apps, but it was still orchestrating hundreds of individual operations. The architecture became cleaner, but the execution model stayed exactly the same. So we made one final architectural change. We stopped thinking in technical operations and started thinking in business operations. Instead of saying, create project, create work package, create stage, create another stage, we simply said, create project, here are the parameters, you know what to do. Everything happened where the data actually lived. No unnecessary network traffic. No hundreds of API requests. One database transaction, one execution, one consistent result. The result surprised even us. The project creation time dropped from almost 100 seconds to roughly 1 second. Same business process, but completely different architecture. And stored procedures are not the answer to every problem. I'm not saying that. But when you are performing complex data operations, they are incredibly powerful, especially when hundreds of related records need to be created consistently and quickly. And this is probably the biggest lesson I want you to remember today. Put complex data operations as close to the data as possible. Treat Power Apps as UI, not as a database. Same users, same business process, same amount of data. The only thing we changed was the architecture. At that point, the application was finally great. It was fast. The architecture was much cleaner. But another problem appeared. And it wasn't a user problem anymore. It was a development problem. Every new feature, every bug fix took longer than the previous one. That's exactly where we were. The application worked, but every screen had its own logic. Different variables, different naming, slightly different implementations. Everyone solved the same problem, but in their own way. Let me give you one very simple example. Even something as basic as loading variable, which shows the loading pop-up, had a different name in almost every screen. Why? Because nobody ever agreed on standard. And honestly, it worked. Until another developer had to understand the application. So the first thing we did wasn't introducing a new feature. We standardized names. It was introducing consistency. Same concept, same variable name, everywhere. Then one day, our manager came with a simple request. Please update the project filter. We need to change how the current project is loaded. Sounds like a 5-minute task, right? But because that exact logic existed everywhere, we had to update screen 1, then screen 2, screen 3. And thankfully, we only had around 15 screens in Power Apps to update. We have already standardized names. Then we realized something. If every screen performs the same operation, why are we implementing it 15 times? We shouldn't standardize only the names. We should standardize the behavior. And once we did so, we moved from this one to this one. To the clean code where we are not repeating same logic. We are referring it to the specific function. Then we standardize it even more, and we referred all other functions. And this change significantly reduced duplicated lines. We moved from this one to this one. But what is even more important, if the manager came with the same request, then instead of making 3 changes, in some cases 15 or even 50 changes, we were able to update only one line of code, which lives in our single source of truth. And now we might ask, where does our business logic actually live? Well, it depends. During the project, we realized there are 3 completely different categories of logic. The business logic, the user interface logic, and the data logic. Each of them deserves a different home. Once we understood this, every architectural decision became much easier. We no longer asked, where should I write this? We asked, what type of logic is this? Let's start with the business logic. Just a few minutes ago, we saw that every screen was calling the same function instead of implementing the logic itself. And we were asking, where do these functions actually live? Right here. inside user-defined function. Why? Because loading the current project based on the selected filters and the project ID, that's business logic. Checking whether the current user can edit the project based on their permissions, that's business logic. Loading data based on the selected filters, again, business logic. There are reusable business operations. They don't belong to individual screens. They belong in one place, in user-defined functions. This is where the implementation lives. Every screen simply calls the same function. So if the business rule changed, this time changing it was so easy. Only one user-defined function, 5 minutes, perfect. We are done. And we didn't reduce the amount of code. We simply reduced the number of implementations. This is what maintainability actually means. Not fewer lines, fewer places to change. So we solved the maintainability of business logic. But not everything is the business logic. We found two more areas where every developer was doing things differently. It was the UI and data logic. These two were still scattered across the application. Let's look back at our app. Here we display the current user, not only in this screen, let's say in every other screens as well. And here we define the fill color of the button. Maybe we want to have the button in green, maybe in blue. But let's say not only this specific button, we want to have all clickable buttons in the same color. None of these are business operations. They describe the application itself. That's exactly where app formulas come in. Instead of calculating these values on every screen where we display user details, or for every property, for every button to define the specific color, we define them once in app formulas. And every property simply consumes them. If tomorrow we decide to change our branding and change the color of all the buttons, we don't update 20 different screens and 50 buttons. We update one app formula. And every screen immediately gets the new value. Great. Business logic had one owner. Application logic had one owner. But one problem still remained. Every screen was still rebuilding the same data. Imagine this gallery. And let's say every project needs also to display the number of work packages, the number of stages, maybe the overall project status showing if related work packages are approved or no, maybe the latest execution date of related work packages. And then suddenly, one gallery contains dozens of lookups, dozens of filters, and calculations per one row. This is what the gallery was doing for every single project row. Count related work packages, count the stages, calculate the overall status, find the latest execution date. And this was only one gallery. The same logic appeared in other screens as well. So we had two problems. The app was doing too much work, and the same data logic existed in multiple places. That was the moment when we changed the responsibility again. Power Apps should not understand how all these values are calculated. It only needs the final results. So we moved the joins, counts, status calculation, and aggregation into SQL. The SQL view became our single source of truth for the project overview. It joins the necessary table. It calculated the counts. It resolved the status. It returned one clean data set to the application as a SQL view. And in Power Apps, all of those formulas disappeared. The gallery simply consumed the SQL view. One query, one definition, the same result everywhere. From a maintainability perspective, this was the real improvement. If the definition of project status changed, we updated the view once. Every gallery, every report, and every screen immediately received the same result. This became our model. Business logic had one owner. UI logic had one owner. Data logic had one owner. And it doesn't mean less features. It means less places where the same logic could exist. And as a side effect of good maintainability model, performance also improved. We reduced repeated lookups. We reduced calculations per row. And we moved the heavy work to the system that was designed for it. By this point, we had already solved a large part of our performance problems. And it's because good architecture improves performance, and good maintainability improved it even more. But there are still a few application level lessons worth mentioning. The first lesson is actually a very simple one. Once we moved to a better architecture, we started looking at individual screens. And we noticed something interesting. We were loading completely independent data one after another. Projects, then work packages, then permissions, then users. Every request waited for the previous one to finish, even though they had absolutely nothing to do with each other. Instead of loading everything sequentially, we started loading independent requests in parallel, simply by wrapping them inside the concurrent function. Nothing else changed. Same requests, same amount of data, just a different execution model. In one of our screens, loading time dropped from 6 seconds to around 2 seconds, just because we stopped waiting to finish the line before. 3 times faster, without changing SQL, without changing infrastructure, without changing hardware. We simply allowed independent operations to run independently. Sometimes performance isn't about doing less work. It's about stopping unnecessary waiting. The second lesson was to stop loading data we didn't actually need. Earlier, when opening a screen, we simply loaded the entire dataset, every column. But then we ask ourselves, What does this screen actually display? Just the project name, the country, and the status. So why we were loading 20 columns when we only needed 3 of them? The same applied to the datasets. Some screens loaded projects, documents, comments, work packages, stages, and even though the screen only displayed projects. We started asking 2 simple questions. Which column do we really need? And which datasets do we really need? Because every unnecessary request costs time. Don't load everything. Load exactly what the user needs, exactly when they need it. And finally, delegation. Every Power Apps developer has seen this yellow warning. At first, we ignored it. The application still worked. Until the amount of data started growing. Suddenly, users started missing records. Delegation isn't only about performance. It's also about correctness. If you are building enterprise apps, learn delegation. It saves you before performance even become a problem. Looking back, performance wasn't solved by one optimization. It was multiple small decisions. Every one of them removed a little bit of unnecessary work, and together they made the application faster. At this point, we finally had something we were proud of. The architecture was clean. Developers enjoy working on the project. The application was fast. We thought we were done, but we weren't. Because another challenge appeared. Not while writing a code, but while releasing it. And just like architecture, our deployment evolved as well. It's Friday 2:45 p.m. Developer clicked edit and finished the latest changes. He saved the app and then he basically clicked publish. That was our first version of deployments. Completely manual. Edit, save, publish. And then you hope nothing breaks. All we had was only one environment. And honestly, for a small application, this worked perfectly. This wasn't wrong. It was simply enough at that stage. Then our solution started growing. More developers joined the project. More users started relying on the application. And we introduced our first production environment. Production became read-only, so only end users work there. And the whole development happened in that environment. Developers saved the changes, published the customization, and exported the solution. We imported the solution to the production environment. We updated it with the new version. And it was ready to play for the end users. Deployments were still completely manual, and eventually, the biggest deployment problems weren't technical. It worked. But the problem were human. We exported the wrong version. We forgot to publish before exporting. We imported it into the wrong environment. Every release depended on somebody remembering every single step how to do it. The next step was introducing Power Platform pipelines. Suddenly, deployments become much simpler. We click one button, deploy, and the platform exported the solution, imported it into the next environment, and completed the deployment for us. It was ready to play. That removed a lot of manual work. But after a while, we understand that deployment automation isn't the same things as release management. Because we still needed testing. We still needed approvals. And we still needed the governance. That's when we moved to Azure DevOps. Deployment became part of our engineering process. And every release was automatically built and created as an artifact. Every artifact had its own deployment number and version, which also means that the rollback became possible. Before production, the solution was automatically deployed to test, and testers always received exactly the version that would later reach the production environment. After testing, the responsible engineer reviewed the release, approved it, and only then the deployment continued automatically to the production environment. Just like our architecture, deployment evolved step by step. We didn't jump directly to Azure DevOps. Every new version solved the biggest problem of the previous one. We finally knew how to build the fast application with clear architecture. We knew how to maintain it. We knew how to deploy it. But one question still remained. How do we know it's still working after deployment? How do we know it's not failing for the end users? How can we build the trust that the application is working for the end users? When people see monitoring, they immediately think about dashboards, about application insights, about Power Apps Monitor. And yes, these are important. But for us, monitoring meant something much broader. The first thing we introduced wasn't another dashboard. It was proper error handling. Every our critical operation was wrapped in if error. In other words, it's the same as strike-ahead logic. If this one fails, if there will be any problem to save a new task, then do this one instead. Doing so, every unexpected exception was stored in our database. Instead of users saying something failed, we immediately knew who, when, where, and why. But storing the error wasn't enough. Somebody had to know about it. So every critical failure automatically created a notification. We didn't wait for users to report problems anymore. For some business critical solutions, we went even one step further. Every morning, automated playwright test opened the application, verified the SQL gateway by checking whether data was loaded correctly, and confirmed if the application was healthy or no. That was our health check, how to check if the data are loaded. If something failed, we knew before the user even opened the application. Another thing that saved us countless hours was something extremely simple. Every record stored who changed it and when somebody changed something. Suddenly, debugging became much easier. We no longer asked who changed this, but the application already knew. Monitoring isn't only about collecting telemetry data. It's about reducing the time between the problem happening and somebody knowing about it. Before, users were our monitoring system. Today, the application monitors itself. Looking back, we actually adopted many different technologies. Power Automate, SQL, user-defined functions, SQL views, Azure DevOps, monitoring. But none of them was the real solution. Every one of these technologies simply solved the biggest problem of the previous architecture. Every change started with the question, not with the technology. We never asked, should we use the SQL views? We asked, should Power Apps really calculate all of this? We didn't ask, should we use Azure DevOps? We asked, should every deployment depend on somebody remembering manual steps? The technology was only the answer to that. Looking back, there wasn't one magical optimization. There wasn't one feature that suddenly made the application enterprise ready. It was hundreds of small decisions. Everyone removed a little bit of unnecessary work. Everyone reduced the complexity. Everyone made the next feature a little easier to build. If I compare where we started and where we are today, we no longer think about Power Apps. Before, the UI creates data. Nowadays, UI collects inputs. Before, we had the logic everywhere. Now, we have the single source of truth. From the manual deployments, where people need to remember every step, and there is huge risk of a human error, we moved to the automated releases. Before, the user reported if something was failing. Now, the system tells us if something is wrong. We think about performance. We think about architecture. We think about maintainability, about deployment, and we think about monitoring. And that's probably the biggest change. Enterprise applications don't fail because of Power Apps. They fail because we keep treating them like prototypes. So don't wait until your application becomes enterprise software. Start making enterprise decisions much earlier. And your future developers, your future users, and probably your future self will thank you. And I would like to thank you as well. And I'll be so happy if you can rate my session, follow me on LinkedIn, and now I'm welcome to answer questions. Thank you again.
There was a question, thanks, Radovan. There was a question around optimizing SQL queries using stored procedures. I'll lift it up for you, or you can find it. There's basically what can we do to improve efficiency when we don't use a SQL database that has stored procedures? My suggestion was that you might have to go back and re-architect and find your inefficiencies and create a stored procedure. I mean, it's hard work, but that could be the answer.
Yes. For us, it was quite simple to start with the SQL, because when we started like developing the application, we already had some kind of like foundation created in the SQL. We already had the records, we had the relational database. So for us, it was quite easy to start with that. And that's why we decided to test the stored procedure, how they perform. There wasn't doubt about that, to try it out and see the performance. And the result was incredible. It also like surprised even us, like how fast it was. And I'm not saying that the stored procedure is the answer for everything. Of course, it's not. There are also like different options to do so. It depends on the solutions, of course. It depends like what's the problem. But there are also some other ways. You can have in the Dataverse, you can also connect it to the Power Automate. You can use the custom code connected as a function in the Dataverse, and you can have also the custom procedure to work on the performance. So there's not the solution to everything, but for us, it really worked great to using the stored procedure.
Just a follow up to that. Any other? My brain's a little spongy from being up all night, but I'm sure there's other ways to go about this. Like you said, it doesn't have to be stored procedures or SQL, depending on the systems you use. This is what cubes are for. This is where you bring in different data sets depending on what kind of data you're trying to formulate. So any other suggestions on strategy outside of SQL or stored procedure?
Yes, I can see another question pop up in the chat. If you were starting the project today, would you still choose the SQL instead of Dataverse? I mean, that's really like good question. And the answer is, as I said before, it depends. It depends on the requirements, same as Bobby said. Because Dataverse that's excellent platform. There is like no doubt about it. And I would absolutely recommend it for many business applications. But as I said, in our case, we already had the SQL ecosystem, so it was like much more easier for us to implement that. So SQL also allowed us to use the stored procedure, to use the SQL views, and also like the existing infrastructure that we had. So for our scenario, I would still choose the SQL in the beginning, but I wouldn't say it's the answer like to everything. The right technology depends on the problem you are trying to solve.
Cool. Well, thanks, Radovan.